I'm not going to tell you that I'm an absolute expert in wind farm development, because I'm not. I know how they're built. I've driven around them for a long time, and they keep, the individual turbines keep getting bigger. So this particular project is a big project. It involves very large equipment, and looks like it's going to involve things on the order of, on average, about 5 megawatt turbines. It's a real big turbine. I'm not going to talk about you're getting infrasound issues, the lights blinking at night keeping you up, or having some sort of epileptic seizure from the movement of the things. And I'm sure all those things have happened. I'm going to mainly focus on the wind farms, this particular karst environment, and things that you can do to try to protect yourself in some ways. Okay, so the first few slides here basically it's kind of like taking on the chicken industry. You are not taking on, bring your lunch. The wind industry has been growing vastly by leaps and bounds over the past few years. Oklahoma is like the #2 wind state as a state. So the number of jobs that are projected is 600,000 by 2050. That could be pie in the sky. But in 2023, hard job number is 120,000. Those are things politicians listen to, and so the fight you're taking on is not small. It's the 4th largest source of U.S. electrical power, but the fact that it's only 11% of 2023 generation tells you that fossil fuels are still well in advance in hydropower, well in advance of wind. Okay. That's just to show that generation and capacity have grown enormously over the past few years. And this project is part of that growth, or would become part of that growth. Now, in the U.S., wind power has pretty much stayed out of most of the eastern states, and certainly in Oklahoma, up until the recent ill-fated Osage project, it had stayed pretty much west of I-35. But that's currently changing. And you can see why in the upper little diagram. The wind is stronger in the middle of the country, stronger and up to the north, and that's where wind energy went. This is not as favorable an environment for wind generation, but you sort of run out of places to put it, and there you go. Don't have to worry about that. Okay, so in Oklahoma, if you've driven out west or the southwestern part of the state, we have a large number of wind turbine installations. And interestingly, the U.S. Geological Survey, I got this graphic off the internet. The U.S. Geological Survey maintains a database that records the height, width, grandparents, everything there is to do with every single installed turbine in the U.S. So you can look to see in any one of those dots, when you zoom in, what the capacity of that turbine is, when it was built, how tall is it, the whole business. So there's a lot of information concerning these. It's available. Now, the project here is, I understand, is the Rocky Hollow Wind Project. And Pam, I tried my best to geo-reference that diagram, but I couldn't get it done. So this is roughly the approximate area of this. So it looks like a little bit to the west of where we are currently, and slightly into Mays County. And it's about 3.5 to 4 miles north and south of Highway 412. 56 turbines, construction alleged to begin in 2028. It's going to be a 250 megawatt capacity. And they always say at homes that it could be run in a data center someplace. But the average of this would be 4.46 megawatt turbines. 5 megawatt turbines are really big, so this is going to be really big. Okay, now, this was just as a point of beginning. I wanted to see, just applying what I generally apply in litigation matters. I started looking at governmental resources to see where things are. Well, I discovered that permitting for these is pretty much only involves getting an FAA permit for each installed turbine. But you have to, as the wind farm constructor or operator, you have to actually make a very specific declaration about where that turbine is exactly for planning purposes. As of yesterday, there are no postings anywhere within the Corporation Commission website under Public Utilities for the Rocky Hollow project, although there are dozens of others that are posted. So nothing yet, as Pam was just saying. Okay, so let's talk a little bit about Karst. You live on Karst here. It's not quite the sinkhole plain outside of Mammoth Cave, but nonetheless, it's Karst. And really, what Karst is a normal geological circumstance. It's just that the fractures that are normally present in rocks have become enlarged by dissolution. It's soluble rocks present near the surface. So here, our soluble rocks are limestones, and to a lesser extent dolomites, which are calcium and magnesium carbonate, less soluble. Out west in Oklahoma, the karst is developed in gypsum rocks. Anybody here ever been to Alabaster Caverns? Good, you should go. It's the 15th longest gypsum cave in the world. The other 14 are in Kazakhstan, so it's kind of a big deal here in the United States. But that's it's distinctive hydrology. Why is it a distinctive hydrology? Because it's a fracture-dominated system. Generally, when people think about groundwater, or at least it's often, I don't know myself, when you're teaching about this in a class, you have a box of sand. You put water in one end and pass it through a porous medium. So you have between grains, intergranular porosity, and those pore spaces are connected by pore throats that provide the ability for fluid to move through that space. So you know as well as I do, if you tried to suck water through sand, it's kind of hard to do, right? But it can come in many places through the seam or front. In fractured ground, like karst regions, where you have breaks in the rock and sometimes they're enlarged into caverns, the fluid can move really fast. It's going to move. It moves just like electricity. It moves through the path of least resistance, and so it'll move through the fractures. But the limestones tend to be relatively low permeability rocks and not a whole lot of storage of water in them. So in a fracture-dominated pore system for an aquifer, the water can move really fast, but you run out pretty quick because we drain the fractures. So, and the other problem with fractures in rocks, especially in karst where things have been dissolved, we have a spot near the surface that's unsaturated, it's not full of water, and then eventually reach a saturated unit, the so-called water table. The fluids that may be moving down from the surface are not necessarily moving down any predictable path. And the fluids that are moving through the fractures are moving along the fractures. And ultimately, that's downhill or down gradient. So it's not rocket science, it's going downhill. But the fractures themselves can take oddball paths, or their interconnectivity can take oddball paths. And so karst terrains are notable in having unpredictable hydrology, unpredictable hydrogeology. Okay, and just so you walk away with a term, my wife says I have too many terms, I probably do. But what we're looking at in a karst space is what's called secondary porosity. If I have a bucket of sand, all the spaces between the grains is termed primary porosity. It's porosity or holes that were there when you started. Secondary porosity are holes you made after you hit a rock. And so karst is dominated by fractures and secondary porosity, pore space that's made after a deposition, lithification, so it's older stuff. Okay. A lot of terms in karst are weird because it was originally, not really originally, but the person who popularized the description was from Slovenia or Croatia. Okay, now, here's the second thing I looked up. Karst is the term mentioned in the Oklahoma Administrative Code. I thought somewhere within the vast, the plethora of regulations that no one actually reads, that the state of Oklahoma has, we would find the term karst, and indeed you do. But what you'll note, and I've provided in here all of the Oklahoma OAC, that's Oklahoma Administrative Code, chapter 252, 51, going on to the main heading, or you can search the administrative rules and just look for karst. But they have to do with the DEQ, the Oklahoma Department of Environmental Quality regulations. In almost every instance, management of solid waste, disposal of fly ash, coal combustion solids, septic pumpers and transporters, Oklahoma pollution discharge elimination standards, land application of biosolids or sewage sludge, or public water supply construction standards. What it says is, except for the last one, don't do it on karst. That's what it says. But otherwise, karst is not mentioned otherwise in the Oklahoma Administrative Code. And so there are no provisions that specifically address that issue with the Corporation Commission, for example, or any of their entities. Okay. Now, sometimes yes, sir.
In that previous slide, is the administrative code basically talking about what goes on top of karst?
Yeah, what goes on top of karst. Yeah, that's talking about,
It could flow through.
yeah, you don't put anything on top of karst that might go into the karst. And then, for example, under poultry rules, should they be followed, if you're spreading poultry waste on the ground, you have to stay within, beyond 50 feet from any known sinkhole. Not that's going to buy you a lot, but at least it's something that's recognized that that's a conduit into the subsurface. Now, despite the fact that we think of karst as being kind of a rare thing, it's really not. It's actually quite common. Here's the global distribution of karst, not that that's necessarily directly relevant to you, but karst is a very common circumstance geologically, and it has specific problems with respect to production, construction, with respect to living on top of it. You probably remember the guy in Florida lost his brother-in-law down a swallow hole. I don't know if he's happy or not about that, but it's a very common feature on Earth. And if we look at the United States, you'll see it's a very common feature in the United States. Happens a lot in Florida, profoundly karst, lots of karst systems along the Atlantic coast, and in Ohio, and elsewhere, Minnesota, Wisconsin, and here. There's you. So if we look very specifically at Oklahoma, they're really looking at two kinds of karst systems. Both of them involve rocks that easily dissolve under Earth's surface conditions. So here, we're on the western edge of the Ozark uplift. We are sitting on a carbonate terrain. These are mainly Mississippian carbonates exposed here at the surface. And that's also true into, we'll call it I-35 land, even though it kind of isn't that piece. Limestone karst, northeast and central part of the state. The western part of the state has gypsum karst. And if you've ever driven around in Blaine County or anything Blaine or Freedom, Woodward area, you'll see karst landforms that are formed in calcium sulfate and gypsum. Okay, so there's the Rocky Hollow Wind Project area right here, right on top of karst. Okay. So the project is being built on karst. By the way, that's not unique among wind turbine farms. Okay, so what are the common features of the karst landscape? I've alluded to these, but I thought a picture might be kind of handy. First of all, if you start at the bottom, you can see these large cavernous, so-called cavernous porosity. I mean, literally big holes, walkways. In an earlier and more adventuresome period of my life, I was a cave explorer for a while. And these are literally places bigger than this room. underground, walking through. I don't know if anything like that exists here, but certainly I've been in things of that nature. Been in caves where you've taken 8 hours to get to where we just ran out of gas and had to stop for the night, slept and kept going the next day. Okay, so large cavernous porosity. You see these vertical lines? Those are things in rocks that are called joints. Rocks are extremely strong in compression. So we built a really tall rock wall, and the rocks at the bottom don't crack. But rocks are extremely weak in extension. Pull apart, breaks. When the Ozark uplift happened, lifted up part of the land, began eroding off the surface of that, the rocks beneath them, including these limestones here, were exposed to less and less confining stress. Less pushing it down, nothing pushing it down, the rocks break. You can sometimes see that in a stream bed where there's limestone exposed. You'll see a set of what are called joint sets, and they'll be at right angles to one another, break and a break at right angles. That's by the way called another term, conjugate joint set. Not that that's meaningful to you, but it's just we have breaks in the rock. Those breaks become enlarged by the passage of water through them. The water is often charged, if there's vegetation above it, charged with carbon dioxide. The carbon dioxide makes the water a little more acidic. It dissolves the limestone. So as that water moves down through, the joints become expanded. And those joints are the primary pathways into groundwater. It's just like you have a pipe, actually a long slot sometimes, sitting in the ground, taking that down. From time to time, and it's not super well illustrated here, but you'll see this opening at the surface. And those are sinkholes. You know, once I get the rock below, rotten rock, the rock starts falling away, and I open up to near the surface, I may have that gap bridged by soil. And then one day it dries out, or you get too much water from a rainstorm, and it collapses. That's called a collapse feature. So sinkholes also called collapsed goal lines, but they're sinkholes, you know, or swallow hole. At one time, at least where I was in Ohio for a while, they were very popular spots to dispose of avian mortality from poultry operations. So we had the pit of the 10,000 turkeys, for example.
And we have a lot of the sinkholes here.
Yeah, and that's really important. Okay. But that's kind of the idea. You can look at this at your leisure. Here's drawn what's called the saturated zone. All that means is all the pore spaces that are accessible by water are completely full of water. Sometimes that's called the phreatic zone. People try to fool you with that. It just says it's all full of water. Above that is the unsaturated zone, or the vadose zone. Now, the flow in the saturated zone, mentioned before, is predictable in the sense that it's going to go down a gravitational gradient, and we can measure the head heights, or measure the water fluid levels in multiple places, and we go from higher heads to lower heads. Say, well, it's going that way. Its detailed path may be doing some number that's very different from that because it's following joint traces in the ground and following the cavern. Okay, but we pretty much know where it goes. In the unsaturated zone, we only know that it's going down. In some areas, you can kind of think of this just like a bunch of broken china, and I put water in there. It's not going to go with the overall hydrologic gradient. It's going to pass with whatever local gradient is put in place by slanted rock surfaces. Okay. We live here in something that's called mantle karst. So if you've seen a road cut around here, and I'm sure you all have lived here long enough to have seen them, you'll see this very thin, dark, organic rich soil at the top, maybe. Trees growing in it. I know you can see this if you drive up toward Lake Uchi. Below that, you'll see a reddish soil, and within that reddish soil, there'll be chert nodules. So what's going on there is the limestone's dissolved in place, and it's left behind the things that don't dissolve that are in the limestone. So it's left behind clay minerals, a little bit of silicate sand, And the chert are things that basically derives from sponge spicules. The silica is dissolved, moves together, and forms these microcrystalline, really horrible things to have to ever crawl over if you've ever been forced to do that. Chert nodules. So that's the mantle. So that hides a lot of the underlying karst. So if you look at this figure, the one that's on the left here, it lays out these bedding planes and joints and such that are going in different angles, and we have a variable surface on the hard rock that's all pretty much buried under karst. Now with respect, and I'll probably repeat myself, but it's highly variable. I took a look at about 50 boring logs from the Oklahoma Water Resources Board database of wells, and often you can't really trust drillers' logs because, well, it's red and it's brown. They're not necessarily trained geologists, but I can trust them to know dirt from rock. And so they'll talk about overburden or chert, that's loose material. And then they'll talk about a limestone. And so we're able to take a look at the thickness of the karst mantle with some degree of precision, just from readily available free driller's logs you can pull off the internet. And the deal is, it's highly variable. And why is it highly variable? There's a karst surface below it with a lot of topography on it that we don't see at the surface. And the karst mantle is anywhere from 10 feet to 175 feet thick. So the karst mantle is variable, and you won't know that just by walking around on the surface. Okay, so mantle karst hides the rock and hides a lot of what's going on. Okay, so in karst hydrology, hydrogeology, water shows up in this by what? By rain. That's how new water shows up, precipitation. It infiltrates through the soil, very fairly thin soils here, thin and rocky soil, and through whatever the rest of the karst mantle enters the unsaturated zone. Remember, it's moving with where the holes tell it to move under the influence of gravity, and ultimately it hits the water table. That water table can move up and down seasonally. When it hits the water table, then it moves down gradient. That is, it's going to go downhill. Typically, or frequently, you'll see it discharging into streams. So many of the streams here, hot summer, and you haven't had rain for a long time, yet the streams will still have water. That's because their flow is supported by groundwater. So base flow, when you aren't putting rain into the system, it's being supported by groundwater. So aside from the fact that under Oklahoma water law, there's a distinct difference drawn between groundwater, which belongs to you, and surface water, which belongs to the state or to the tribes that you're talking to that day, it's all the same thing. One becomes the other. But the most important, remember, it's going down. All right, so here's Delaware County, where you are, and we're sitting here in what's called the Springfield Plateau Aquifer. It doesn't have any sort of aquitar, like an impermeable barrier sitting between the karst mantle and your aquifer, the water you produce. Most of the wells here, I'll put it on this slide, but the wells on average, the domestic water wells in Delaware County are at about 350 feet below grade. So they're accessing the upper portion of the Springfield Aquifer, mainly the boom. Whereas the agricultural wells that are not used for irrigation, chicken house wells, are generally advanced to 700 some feet and are basically trying to access the Rubidoux, which is a much deeper and much more expensive to access source of water. So most domestic water wells, how many of you in here have a water well? Okay, how many of you have access to rural water? Okay, rural water is fairly limited in Delaware County, near towns, but it's most folks are groundwater supply. So you're drinking from water that's basically in the more shallow unit and is far more susceptible to pollutants coming from the surface. That's where we are. Bunch of names. We hear people talking about the Moorfield, the Keokuk, and the Boone Formation, or these things called members of the Boone. That's what they're talking about members of this aquifer, and they're all limestone. Okay, aquifer thickness here in the Springfield, here's our area. They're saying on the order of 200 feet of saturated thickness. Okay, so here's a map. Let's see how seeable this is. The blue dots are all domestic water wells, and these are the locations, and I will tell you this, they can be a little red. They're listed in the Oklahoma Water Resources Board, and the red and white circles are agricultural wells not used for irrigation, so chicken house wells basically. I think there's one industrial well, I'm not sure what they're using that for. But bottom line is, there's a large density of water wells here. We know these aren't all the water wells that are here, almost certainly. We'll talk about that later, but there's a lot.
Wow.
Okay, let's talk about Karst structures. And you can sometimes see Karst-like effects happen around leaking water pipes in urban settings. If water starts leaking, it starts running along the sides of the pipe, begins transporting sediment with it, and then the surface collapses. That's very similar to what happens in a sinkhole that is collapsing. So, as you might imagine, it's hard on the structure. And the reason is, it's not static. That's the most important thing to remember. When you say swallow holes, they weren't swallowed holes. These are places where there's active downward movement of earth materials. Not on a continuous basis. Every time you get a really hard rain, maybe every 20 years, another dollop of mud goes down the hole. Plus, the landscape, the limestone itself that sits below grade, below the mantle, is continuously dissolving. Now, they're geologic scale processes, so that's tens of thousands of years to really dissolve big holes, but the swallow holes are sort of waiting to collapse. I just relate one story. In my early caving days, we used carbide lights at my age. So I was off to the side of this stone pit with a big tailless cone, giant, the size of this room. It's a huge cone. So I'm sitting up at a high place, putting new carbide in, and my compatriots thought that they would try to see if they could get up past the tailless cone. Well, somebody pulled out a rock, which turned out to be the key rock in the pile, and the next thing I heard sounded like the New York subway, except that it was right in my face. Huge piles of rock flying past. I thought those guys would kill. All I could think of was, well, I hope I remember the way out, because there's no chance in unburying these characters. But they had scurried up into a little dome pit. But that happened with movement, just one guy moving one rock, tons and tons of material cascaded downward in seconds, didn't run to the surface, but now there's a hole between us and the surface, an unfilled gap. And so it could certainly collapse. There's a collapsed sink over there. Okay, runoff in fields often gets swallowed by these swallow holes, and that's a direct discharge or recharge into groundwater. Okay, this is really interesting. I sent Pam the reference, but there's a group that looked at sinkhole susceptibility. So it's a little semi-theoretical, but it's interesting. What they did is they looked at all the factors involved in sinkhole collapse across the United States, and then buttoned up the landscape into little squares and calculated, how probable is it given rainfall, the kinds of karst that are present, the infrequency or frequency of rainfall. And just put it this way, red is bad. It's not the worst, but it's bad. And in fact, much of Delaware County is within a high susceptibility area for sinkhole formation. So that's kind of interesting. Okay, wind farms and karst. Remember, the wind farms are out west. a lot of the western Oklahoma is in fact karst. And when I looked at this map, I said, gee, are they following karst features? And indeed, that might be true, certainly in the western part of the state, because the areas that have heavy karst development and are heavily karsted at the surface are generally lousy for any kind of agriculture, including you lose cattle down holes there, so nobody can do much with it. Therefore, they're great places to put wind farms because you really can't use it for much help, unless you want to dig up the gypsum and make wallboard or something. So that's interesting. Mainly on gypsum karst, a few on carbonate karst. That's our friends up there in Osage County. Okay, so wind power and karst risk. Something that, and wind power companies are not, repeat, not ignorant of this as an issue. Well versed. Pam sent me some testimony from Ohio in which the Supreme Court denied a permit to build wind turbines, basically on the premise that they had not considered karst in their workup of siting the wind farms. I also sent her if you've ever driven down I-35 and gone through Honey Creek Pass, you'll see those wind turbines down there. Every one of those wind turbines was sited after a geophysical survey to be sure they weren't putting it on top of a karst feature. So the whole business of risk management for the wind tower operator in a karst terrain is do not put your equipment on top of an obvious karst feature. And what I want to say here is that it's not a difficult thing to do a karst survey, and it's something that it's almost certain, although you've got a good scheme here. Should that scheme fail, it's almost certain they're going to build. And if they go to build, you really want to be sure that they build in a way that doesn't endanger you or them in either way. Okay, so typically, this is from this paper by Bankston and Johnson. I don't know if I sent that along, but they're, what do you do first? Well, you do some really easy things first. I can look at maps and air photos, and I can sometimes see sinkholes in those without doing anything else. Read relevant literature. There's not a whole bunch, but talk to cavers, local cavers who've been around. Landowners, often landowners know if there's some karst feature on their property. And geologists who probably are fairly clueless and sitting back and like me. But nonetheless, you can do basically a desktop study and look for karst features. Okay. Now, once you have looked at those, the obvious ones, anything that's truly obvious, you would avoid. And so any place you're going to site a wind turbine, otherwise you still need to be aware that there's karst present, and you need to make a survey of some type, geotechnical survey in essence, to be sure that you aren't going to stick it on top of sinkholes about ready to fall in. Okay, so site reconnaissance was that's a dignified way of saying we went out and walked the field, or walked with a landowner in the field. Pit test, how deep is bedrock? There are other ways of doing that. We do a lot of this stuff. We do electrical resistivity tomography and electromagnetic terrain conductivity work. And there are things that have been used to look for karst features. Gravity, measuring the gravitational field or gravitational gradient as you go across, a very sensitive way to find voids, or to find things that are filled with dirt instead of rock. And those can be flown airborne. So you'd like to stay down on the deck as much as you could, but you can survey a large area really fast that way. Ground penetrating radar, which you probably see, often you'll see that on the History Channel with guys looking for Hitler's grave or something, or looking for Roman ruins in Britain. But it's a useful tool if the geologic conditions are right. You can use passive and active seismic methodologies today. And here's one that's really easy, remote sensing. You can either use photogrammetry, and this is actually really simple these days. I hire a guy to do this, I would say all the time, at least twice a year. Our vendor in Oklahoma City, if we have a particular job or we're interested in terrain or topography, he'll fly it with his aircraft and takes his photogrammetric photographs of that. And depending on how much money I'm willing to give him, he can give me down to 1-inch resolution. That costs a lot. But I can get 3-inch resolution for half that price. The deal is you can fly fast. I mean fast. I asked him to go fly a section, 2 days later. He says, well, if I was going on a trip to Kansas, we flew over your stuff, here it is. That can be acquired really, really fast from manned aircraft. There are certainly people can do it with drones. Drones are nice, but once you start looking at a big enough area, it's not so nice anymore. The other methodology that's used is LiDAR, which is light distancing and ranging. It uses a laser shooting down at the surface and you're measuring the elevation of the surface. The value of that is it can look through trees. So it can look between the trees. In essence, you can generate what appears to be a surface that you can't do photogrammetrically. And boring is sort of the last resort because that's a very slow rate of fire piece. And sometimes you camera inspect the boreholes to see if there's a cave sitting off there. Okay, I'll just give you some. I wanted to just tell you that these geophysical methods are around because they're around, tried and true, and been used for 100 years. Don't let anybody tell you this, oh no, we can't possibly do that because that's experimental stuff. It's not. This is electrical resistivity tomography. I didn't bring pictures of what it looks like, but the gizmo actually looks like an extension cord with tumors. Attach electrodes at the surface. Then I'm looking for all the pairwise. I inject current, and I look for all the pairwise resistances, and then model what the Earth must look like below that to arrive at this, which is an so-called inverted model. But the big deal here is it's a 2-layer system. The green stuff is conductive, and the bright colored stuff is not so conductive. Green stuff's not resistive. It is very resistive. And it's saying I'm looking through a karst, weathered rock, soil, and in fact, I'm seeing an area there, the blue spots that are very low in electrical resistance, and that's more likely than not a water-filled cave. So what do? You say, well, gee, we think we have a water-filled cave. We run a drill rig out there, poke a hole through that anomaly, that target, and there it is. Indeed, it finds a void space where it's predicted. This is a slow process. We can shoot probably a mile a line a day with this, with a 4-man crew. So this is something you'd use on site. This is the site. We're now going to look at this site in detail. This would be a detailed look. Oh, well, sorry. Okay, here's ERT and gravity. This map not too meaningful, just say there's a sinkhole here. Here's the gravity. Whoop, that seems to be a gravity deficit there. Comes back up. Well, this is the cavity. This is the electrical resistivity profile. Here the red is high resistance, solid rock. The blue-green is stuff that's filled with mud and water. And so that's the sinkhole fill. There's a sinkhole, there's a cavern beneath it. Okay. ERT fence diagram. I can make a 3-dimensional picture of the site. This work done by Todd Hallahan, was at Oklahoma State University. It's actually done in Arkansas on a field next to a river where pig poop was being spread. So here's a sinkhole, see? A little higher resistivity, or higher conductivity, lower resistivity. Surface, whoop, goes down. Okay, ground penetrating radar. Conditions are good. Here's a sinkhole, image it. This is work that I did in New Mexico. In New Mexico, when flowback pits are put in for oil and gas operations, and they're big. These larger internal yellow squares are 700 feet long. They're pretty good sized installments. In Lee County, New Mexico, because it's in Karst, the state of New Mexico requires that a Karst survey be done prior to constructing these flowback pits. You don't put mass on the surface, because if you put mass on the surface and it's a sinkhole, you might lose all that mass from the surface into the subsurface. And so what we were specifically did electromagnetic work there, which involves just walking over the surface with something that looks like a 12-foot long broom and measuring the ground conductivity. So this place is really dry. So any place we find these brighter colors, high conductivity. High conductivity means more water. More water means finer grained sediments. It means a fill. So we identified 2 probable karst features. The geotechnical guys went and bored them. They were, you have to move, we moved the construction. Okay, and then seismic. Here's a joint. Here's a joint. Here's a joint. What's the deal? In mantled karst, the mantle will be a very low velocity unit, and the limestone will be a high velocity unit. So looking at the rate of which sound can propagate through those media, I can tell you if it's full of mud and rocks or if it's solid. And so that's helpful in imaging, because a lot of what you do it looks really difficult, a lot of math and colored diagrams, but in the end, we're looking at a 2-layer system, and we're trying to put energy into the ground and see what comes back at us. And then we look at the shapeology with geologic models. Say, gee, there's a karst surface with mud-filled joints. And then here's a LiDAR. You can easily see the sinks on this. There is blue and the red dots. These are areas that are depressed, that have shown up in this LiDAR image to help us map sinkholes. That's something that could be really useful here, since if you have a lot of sinkholes, sometimes you can't see them just standing on the surface. Either they're too big, or there's too much cover, or the relative change is too small. But when you have an instrument that can look at this in an unbiased way, you look at the map and say, oh, that's a sinkhole. Okay. Let's talk about siting wind turbines. There are lots of constraints on the wind turbine people about siting the turbines. Basically, the bigger they are, the further apart they need to be. And I thought about your campaign. You could actually, it's like a go game, you could actually freeze them out of being able to economically develop this with a relatively small percentage, maybe 30% of the landowners with the land surface area. Not everybody owns the same fraction of land. Within the areas they're going to want to build those turbines are, which is these large flat prairie areas. Yeah. They're not going to build them in a hole. They're going to build them in a flat prairie area. And since they have requirements to be economic, they have to be so far apart, and they need to be, not interfering with one another. They're just wasting their money. So you can essentially freeze them out of an area by controlling some of the surface. I will say this, so the bad end of this is, remember those first slides where this is a big industry and things are happening fast and there's a lot of push behind getting wind industry in place. I would not be surprised that within the decade, eminent domain will become something that's possible. I'm not proposing that you do that, but there will be pressure to do that. As soon as they freeze out a few projects, that'll be true.
Yeah.
So the key answer, karst questions you have to answer when you site the turbine, is it a groundwater recharge area? Because if it is, I need to be really careful here, maybe not put anything there. Are there sinkholes? I sure as hell don't want to be on top of one or on the edge of one. Is there cavernous porosity beneath me? Is the overall rock column strength sufficient to hold up this large point mass? And how much karst mantle am I going to penetrate? How much of this am I going to whack off? Okay. So a stable foundation is essential. As you can see, this was not a stable foundation. The thing that surprised me, and I'm no expert in this, but all the foundation designs I could find really seem to spread the load over a large area, like maybe these big things, 60-foot diameter area or bigger, with very little vertical stay to it. Maybe a 30-foot or 40-foot column going down in, but they're really sort of like sit there. Looks pretty creaky to me. That being said, I'm no expert.
In Tornado Alley.
In tornado alleys, Wind utility is a 2 megawatt turbine, which are generally what you see out west. 300-foot tower. It digs a hole 15 to 20 feet deep. So you want to know how far you're going down with respect to where's bedrock from there. It takes 320 cubic yards of concrete. 5 megawatt wind turbine, 700-foot tower, like 900 cubic yards of concrete. And probably a deeper excavation, although I couldn't find a specific design. The other thing is that's not the only excavation that's going on. There will be utility excavations to both service the wind farm as well as to carry power away. And if you do encounter bedrock surface and you do encounter karst features, the standard fix-up routine, and it's done in pipeline construction too, road construction, is you grout the hole, i.e. you pump concrete into the hole. The thing that we don't know or would not know is how that might impact water quality or groundwater quality, your drinking water quality, and how it might impact the movement of water recharge into the groundwater. It may not do much of anything. I mean, these aren't good, but it's the point. You prefer to avoid the karst feature. You would prefer to be in a part of the karst mantle that's thick enough to take on your foundation without getting down to the bedrock with the possibility of having to grout holes that's what you'd want to do. Okay, so we're worried about disturbing karst mantle, any required grouting, infiltration of pollutants. Now, anytime we make this hole, we generate an interface between the concrete, whatever we do in the utility corridor, that's different, has different, the interface could be likely more fluid transmissive than certainly the concrete or the soil. It's like a fraction. And then when utility trenches are notorious, if ever a spill of hydrocarbons in area of utility trenches, that's not a happy day because it will go in the utility trenches and go everywhere. In the town, anybody ever been to Ringling, Oklahoma? It's a little town west of Ardmore. The truck carrying 8,000 gallons of gas, they overturned there at 2 in the morning. Don't know how that happened. It's a straight road. But it flipped over, dumped its load of gasoline into the town. And the biggest problem was it got in the utility corridors and quickly invaded the town. And of course, there was gasoline floating under people's trailers and such too. But utility corridors, big problem, often one that we don't think about. Okay, this was a revelation to me, probably not to you, but wind turbines use lubricants. Imagine that. They have big gearboxes, they need to lubricate them, they've got hydraulic fluid because they have pitch and yaw control on their moving heads, and there's transformer oils on board. So a 5 megawatt turbine may contain 700 gallons of lubricating oil. Okay, now it just doesn't stay there forever. Anybody change oil in your car in the last month? Okay, well, they change the crankcase oil out on this about annually. In looking at, now this is a little unfair, but not much. In looking at a risk assessment, a real honest to God risk assessment for an offshore wind turbine setup, oil spills were one of their biggest risks, and mainly due to during transfer. So onshore, it's not going to be the same deal. You don't have a pitching deck and hoses carrying oil that could part easily, but still accidents happen. So the turbine could fail. A lot of failures that can cause you trouble, and we're concerned about oil release going right into the aquifer, down around the foundation. It's in a thin karst mantle with a conduit right around it. Okay. But by the way, here's an oil spill coming down the side of a wind turbine. Possible causes. I did not make this up. This comes from the risk assessment. Weather events, tornado and lightning, offshore storms. You get a lightning strike, blows up the turbine. Accidental collision, IE, not EE. Aircraft, plane crashes into one of these. Fires and explosions, for whatever cause. Vandalism, yes, that's a cause. That's surprising, but it's a cause. Maintenance and repair accidents. Somebody's fooling around with it. Structural and mechanical failures, things that you don't predict. Operations errors, oil transfers. All of those are operations that could release variable volumes of lubricating oil. Lubricating oil is not diesel fuel. Lubricating oil is not gasoline. It's not particularly toxic, but I don't want to drink it. Okay. And then there's go back one. Why can't I go back? Prior slide.
Previous.
I'm looking for previous, I'm not reading.
Up top.
Up top.
Number-
There it is.
number
There's
2.
previous. Okay. There's April 17th, 2024 story. Kate County family frustrated by wind turbine leak. In their backyard, oil's coming out of the wind turbine. Everybody's, yeah, we'll be out to fix it. Nobody does. So, recent story. Okay, there's some interesting things. And I think to some extent these may come under the general heading of, gosh, that's interesting. But I'll tell you this, I worked with an attorney who was working with some folks in Nevada who also have a wind farm that's being proposed to come in. And he was wondering whether or not the wind turbines could impact agriculture. Turns out that there's quite a bit of literature that says once you go downwind of the wind turbines, the area is less humid and warmer. So it would increase evaporation rates. Okay, the question is always by how much. But nonetheless, I thought, well, that's interesting. And so he gave me the task of running this to Earth. Why don't you find, my task is call the people who wrote these papers and ask them some questions and see if they'd be willing to talk with us further. So I call them up. Nobody wants to talk. Nobody wants to talk. Well, I don't know. I don't do that work anymore. I don't know. I think that really could be detrimental to the industry. I'm thinking, yep, there's something here. So, but this will ultimately out. This is work that was done in Indiana, in Benton County, Indiana, of all things. Okay. Several investigations have shown that enhanced mixing brought about by wind turbines alters near-surface meteorological conditions within and downstream of a wind farm. The weather's different downwind. Changes to the microclimate surrounding a turbine can impact plant health and the length of the growing season. So what this is supposed to say is they're talking there, this is modeling. And that's one of the issues that I talked to the guys who had done physical measurements. But they're hard to do, man. Some kind of fancy set of drones with instruments, and they're flying them up in three-dimensional picture taking, in essence, or data gathering downwind of the wind farms or wind turbines. And then most of this work is done by modeling, which we can make this up. But the model suggests, and the data tends to indicate that this is, here's the less humid, less humid, more humid, less humid, more humid, that there's a humidity shadow downstream from this. How significant, the rate of which you say, okay, will I decrease soil moisture? There are a lot of other factors. How fast the wind's blowing, how much cloud cover there's present, this, that, and the other. But at key is the factor of what is the difference in humidity between the boundary layer of the grass and the air directly over. Because the bigger that difference, the greater the rate of evaporation, movement of fluid, of air, water into the air. So that remains to be seen whether or not this is significant in any way, but it's just something to keep an eye on because, well, it might be, and the bigger the turbines, the drier the air that would be brought down to the ground. Because if you look at the humidity from the surface going up, it's quite humid here. Sometimes we can do the experiment, walk out the door and start sweating these days immediately. But if we walk down the roof, it'd still be hot, but it'd be less humid. And the higher up you go, less humid typically is. Okay. Lastly, there's our very dear and sweet northern long-eared bat. Bats need friends, and Spelunker will tell you that. And part of their range in Oklahoma is here. My recollection is the Nature Conservancy has there's a term for where bats hibernate just north of Jay, not far away. So this is part of their habitat range. They're an endangered species. Okay, so what can you do? These are things I think you should think about doing. One is locate, if you know your property, locate things you believe to be karst features on your property. And that's not hard. You can look for sinkholes. You can look at, if you're a trained person who can look at topo maps, you're an ag person or a geologist or a soils person, you can look at those maps and see sinkholes and see karst features. You can look for arrays of lineaments, which would indicate intersecting fracture patterns. Do you know of any cave fauna? I mean, we're all into the long-eared northern bat, but there are other fauna that might be interesting you want to protect. So you can use a GPS unit or your phone to record the latitude and the longitude of that feature, and then just prepare a map of your property. It can be on a sheet of paper. I got a sinkhole here, and this really winsome looking bat flying out over here. You have that as a document, and that's something that I'm not going to volunteer Pam, but that's something she can collect, collate, and build into a larger format thing. So with many hands, much can be learned. Okay, groundwater wells near, oh shoot, sorry. I'm hitting this because you can do a groundwater well record search, which we're going to do here momentarily. It's a GIS interface that links the Oklahoma Water Resources Board, well log database, and monitoring well data, or actually groundwater well data. So let's go click on this. Maybe it'll work. It's working. We hope it's fast. It's very good. Okay, so there's our fair state. Okay, let's zoom into Delaware County here. And pretty soon it's going to populate with water wells. Boom, there they are. Now I can, if you get in close enough, it'll start putting section, townships, and range on this. Yeah, here we go. So here's section 4, or here's 21 north, 23 east, section 34. Here's a well, random well. So if we click on that well, come on, you're going to do it for me. I know you are. There it is. Okay, it gives us its latitude and longitude, which look pretty poor. A guy named Don Arnold in the audience here. It gives a public land survey location. It's a 431-foot deep well. It's a domestic well. Initially, it was drilled at water at 390 feet. Not very high yielding, 5 gallons per minute. Okay. It's constructed in May of 1994. So you can do that. More info. Let's see if there's a well log. Yeah, there is. Okay, so here's a multi-purpose plugging and completion report. And here's a log. It said OB, overburden, 100 feet of overburden, gray lime. So 100 foot of karst mantle sitting on top of it. It's all there. I would encourage you to do that. Check out to see if the well that you have is listed in the database. And possibly more significantly, if it's listed in the right county. Because there's, yes sir?
Oh, I was wondering how we could find that website at this time.
Okay, well, I give Pam the information, but this is, if you had this, she can give you the presentation as a PowerPoint. Here's the link. It's showing up right there. So if you put it in PowerPoint, bring it up, you can see what the link is. And this is just it's on the Oklahoma Water Resources Board website. It's under GIS data and maps. And you can learn like I do. I just go in there and see what the heck it is. And that's pretty powerful, but finding out, does it have your well? Is your well in the right place? In fact, is it in the right county? I know there's a fellow who's one of our clients we'll call him Mr. X. I found Mr. X's well, but he lives in Delaware County. I know for a fact he does. And it maps in Delaware County, but the database and it shows it in Delaware County on the map from its latitude and longitude, but it is listed as being in Mays County. So finding that out is useful. Okay. What if there are well records that do not appear in the record search? Well, there is a way to register them. The water board asks you to register the well registration form, which looks suitably complicated. They'll bring up online well registration form. You can go ahead and place well location on this map, which of course is not at all relevant to you, but you can, this is the map of Oklahoma, you can go to where it is. Or you can put it in the latitude and longitude, and it'll show you the point. You can get that off your phone. Okay. Phones are amazing. Directions, how do you get to your house, or how you can drive down State Highway 6 and turn left at, somewhere. And then a lot of things you won't know. The driller, you will know what it's used for, and so additional information. So that helps you, and here's why this helps you. Whenever there's an area of review erected for any purpose, one of the things you look at is what groundwater wells exist within that area of review. And guess what? If your well is not on that, no one sees it. You do not exist as a water well owner or operator, at least for the purposes of the paper study. Later on, you may say, wait a second, I've got a well, and that'll be somewhat recognized, but the ball's already going to be rolling. So having that little piece of information in that database gives people who are planners pause, or they have to account for your needs of water. I think that's kind of important to do. Okay. Yeah, Karst features and water wells. And then anybody have any questions, I'll stand for your cross-examination. Ma'am.
What's the name of the company that's trying to do this?
Oh, that's a good question. There are actually 3 companies. Pam would
Yeah.
be better at naming them. There's a Danish company, right?
Vestas, VESTAS, is the international Danish company. They're the largest turbine producer in the world. And they created a U.S. Subsidy called Steelhead Wind out of Portland, Oregon. Steelhead, like the fish. Steelhead, STEELHEAD. I've got a fact sheet out front. It's got all this on it. Yeah. And then they started last August doing all these leases. And in August, September, they created another little U.S. subsidy called Rocky Hollow Wind. And it's brand new. They just put up their website in April. So this is how they do it. This is part of how the ownership rolls. By the time this comes to construction, none of those companies might even be here. This is just kind of how it happens. So Rocky Hollow has now, Steelhead transferred all the leases to Rocky Hollow. So if you look at the Oklahoma records, it's all in Rocky Hollow's name. So far we have 10 yes leases in Delaware County, none in Mays from this company. So they were early. We caught them early. We lucked into it. And we have 86 neighbors who have said no, not on my land. And that's this map over here. And we have Pat here from Mays County, and they have a map, and they've started in Mays. So this is kind of where we're going. So any other questions for Dr. Bert? He's got to drive back to Tulsa.
This also goes for solar, right?
Pardon?
This also could be solar. If they don't put the wind, they could put solar.
There are 3 solar companies already embedded in Delaware County and all over Mays. Solar is completely separate. They're different companies, and they are currently buying leases, trying to get leases. All up around Grove, there's a bunch of solar already. I checked the records today. I put in wind. under the Oklahoma records, and it'll all come up, and then I just put in solar. And there's about 4 companies, especially around Honey Creek, all up around Grove. It's already happening. And we had one, and I have the lease agreement for one that started coming in between Locust Grove and Locust Grove and Salina. So they're starting to look, they want 1,000 acres, this one company, in Delaware County. So that's another subject. We have to really learn, you know, all these companies. So we have focused on the turbines. They're new, they're huge, and they, I believe, can do some real damage. The solar piece, you know, we're just gonna have to break apart and take that on in whatever way we can. But this turbine one, I think we can stop. And I'm gonna put all my guns behind it so that we can get some sanity here. I don't know that we can stop all the solar. They're here already. I was shocked. I didn't know that.
How long are the leases supposed to last?
30 to 50 years, and they do not come and take away the turbines. That's up to the landowner.
Well, unless you can negotiate it different.
Yeah, well, so far that's not happening.
Well, it's called no.
Yeah, so, yeah, there's that. Hard no.
And even if they would agree to take away leases, there would be, just from my experience in the oil and gas biz, there's no guarantee they'll still have the money to do that when the time comes, so.
Yeah, and it'll be a different company, and how much will they make? There's just a lot of questions to this. We're putting together a fact sheet better than, you know, this was just like, oh my gosh, what's happening? And who are these people? And so now we're really studying. And this is, you know, in our spare time because I don't know why, but it's important. And I love this place. I love our community, and that's why I'm here. And I think that's why you're all here on a lovely evening in the summer. Yes, Grant?
I think it's a small group here, we